Hi, in this video, we're going to be going over how to find the distance between a point and a line on a coordinate plane. Initially, when you see this question type, it seems pretty challenging, but as you break it down, it's actually a series of steps that are not too challenging. So stay with me and hopefully you will find this much easier than you did before you started watching the video. All right, so the first step is to sketch the graph. After we sketch the graph, then we're going to need to be able to find the equation of a perpendicular line, and I'll tell you why perpendicular when we get to that point. Then we're going to find the point of intersection between those two lines, the original and the perpendicular line. And finally, we'll be able to find the distance. And so it's just those 4 steps, and once you can hit those 4 steps, you should be good to go. All right, let's begin. All right, so the first thing is let's sketch that point, -6, 8. So that's right there in pink. Now we can move on to drawing our line. So that is our y-intercept where the line crosses the y-axis. And this is our slope, so 3/1. 3 will be the rise, 1 will be the run. All right, so we always want to start sketching a line at the y-intercept. So we're going to sketch that point right there. And then we're going to go up 3 and make sure you're paying attention to scale and over 1. And we're going to do that again, go up 3 and over 1. Now, we do that as many times as you feel like you need to get your line to be as accurate as you want it to be. And for this question type, having an accurate line is pretty helpful because it does help us to check our answers later on in the question. All right, so here we have our line. And I now want to figure out what the distance is between that line and that point. And so you may recall that the shortest distance is always the most direct shot. So for me to get the distance from that point to that line, I'm not going to go down there, I'm not going to go up here, I'm going to go straight there. And so that's where the perpendicular line comes in. All right, so I am going to estimate this to the best of my ability. Let's use a different color. And I am going to draw a line that I believe is that straight shot line. It's around right here. All right, so that's the distance that I'm going to be looking for. So let's label that so we don't forget. All right, so that's the distance I'm trying to find. All right, so in order to find that distance, the first thing we have to do is find the equation of that line. So let's go ahead and start to find the equation of that green line. All right, so we have a point on that line. That point was given to us in the very beginning of the question. So let's write that down. We have the point, -6, 8. We also have the slope of that green line. You might not realize that you do, but you do, because you have the slope of the perpendicular line. So if the slope of this line is 3, let's write that down. If the slope of the blue line is equal to 3, and we know that the green line is perpendicular, then the slope of that perpendicular line is going to be the negative reciprocal. So we have to take that 3, flip it, and change the sign. So it becomes that the slope of that green line is -1/3. And remember, that's flipping that 3 and changing the sign. All right, so once you have the slope and a point, that's all you need to find the equation. So we can jump in and say either point slope form or slope intercept form. I'm going to go with slope intercept form of a line. We have an x, we have a y, we have an m. Now we just need to find what b is. So I'm going to plug in my y, which is 8. 8 equals m, which is -1/3, x, which is -6, plus b. 8 equals 2, +2 plus b. And now we can subtract 2 from both sides, and we get that b is equal to 6, which tells us that the equation of our perpendicular line, that green line right here, is y equals -1/3 x plus 6. All right, so we're going to need that green line in order to do the next step. We've sketched and we found the equation of the perpendicular line, and now we need the point of intersection. Why do we need the point of intersection though? All right, so let's use a different color. This is the point of intersection. So if we have this point, and we already know this point, all we need to do is find the distance between those 2 points, and that's what the question is actually asking for. So we need this point in order to find the distance between those 2 points. So in order to find the point of intersection, we have 2 equations. We have 2 lines with 2 equations. We have the first line, the original line, and we have the second line, which is that perpendicular line, and they meet at this point. So we're going to be trying to find what the equation is of that point, what the coordinates are of that point. So in order to do that, we're going to set those 2 equations equal to each other. So we have the 3x minus 4 is equal to y, but y is also equal to negative 1/3 x plus 6. So I want to make sure you see where that's coming from. Y is equal to this. Y is also equal to this, which means this is equal to this. And that's what I have written here. All right, so now I'm going to go ahead and solve this by adding 3 1/3 to both sides. 1/3 to both sides. 1/3 x to both sides. And we get 3 1/3 x minus 4 is equal to 6. And now I can add 4 to both sides. And I get that 3 1/3 x is equal to 10. All right, so at that point, you can either divide by 3 1/3, or you can divide by 3.333, or you can divide by 10/3. They're all the same thing. And I prefer to divide by 10/3. So essentially, I just change this to an improper fraction. And when you do that, you get that x is equal to 3. Now, if you are not comfortable with fractions, that's absolutely okay. That's when you can choose to use 3.33333, and you'll get the same answer. So that is our x coordinate, but that is only half of our answer for the point of intersection. We need an x and a y coordinate. So at this point, I can either use my original equation. Let's look here. My original equation is right here up top, or my equation right here with a fraction. Personally, I prefer working with easier equations, so I'm going to use that. So I'm going to write down y equals, all right, let's put another header so we know which step we're on. Actually, it's the same step. So y equals 3x minus 4. So put that here, y equals 3x minus 4. And we know that 3 is our x value, or x value is 3. So y equals 3 times 3 minus 4, which gives you 9 minus 4, which is 5. So now we have our x coordinate, which is right here, and or x coordinate, which is right here, and our y coordinate, which is right here. So our coordinate pairs are 3, 5. That's our coordinate pair. All right, let's take a look at our graph and see if that makes sense according to what we had before. So zooming in here, our point of intersection is in fact 3, 5. So that's why drawing a pretty good graph is great in the beginning, because it does help you to check as you go along. There are several places that you can make mistakes, and it's really good to just keep checking to make sure you're good. All right, so now we have the point of intersection. So we have 2 points. Let's label that. We have 3, 5, and we have negative 6, 8. That was the one that was given in the very beginning. And now we do know how to find the distance between 2 points. And all we need to do is use the distance formula to get that done. So let us go ahead and do that step. Running out of colors. I'll use blue. Okay. So now we're finding distance. And our distance formula tells us that distance is the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so our points, let's make sure we have them. The point that was given, negative 6, 8. Our second point, 3, 5. We can call either one x1, y1, x2, y2. I'm doing this at random. Does not matter which order we choose, whether we went x2, y2 first. Okay. All right, so once you have that, we just plug straight into the distance formula. Distance equals 5 minus 8 squared plus 3 minus negative 6 squared. And we get distance equals 3 squared plus 9 squared. So distance equals 9 plus 81 root. And that gives you root 90. And you can turn that into a decimal. I don't believe this can be simplified any further beyond that. And that is your final answer. All right, hope that helped.